In this video, I'll be helping you with the ALEKS problem type called partial fraction decomposition with distinct linear factors. We're asked to use partial fraction decomposition with this expression, and our first step will always be to find the factors in the denominator. So this denominator is factorable. We can write x squared plus 3 times x by factoring out the x and leaving x plus 3. And this is important because now I know the form of the partial fraction decomposition, where the first fraction will be over x and the second fraction will be over x plus 3. And our numerators that we're going to have to find, for now I will call a and b. And we can take this expression and start solving for a and b. And recall that our process here is to start by just getting rid of all of these denominators by multiplying by the lowest common denominator. And by design, this left-hand side is the lowest common denominator. We would want to multiply everything on the left by x times x plus 3, and each term on the right by x and x plus 3. So both the a and the b are times x plus 3. This helps simplify things considerably because on the left-hand side, that denominator cancels, leaving me with 3x plus 6. On the right-hand side, we also have canceling, and I'm left with a times x plus 3, and then canceling the x plus 3's in that second term would be plus b times x. Now that we have this expression, we can start choosing values of x to get some of these terms to cancel. So for example, if I let x equal 0, then the right-hand side, the b term is going to cancel. The left-hand side, 3 times 0 is 0 plus 6. And then a times 0 plus 3 is just 3. The b term has canceled, so I can solve for a and see that a equals 2. And then similarly, from this same line, if I wanted to cancel the a term, this time I would choose x equals negative 3, which the left-hand side gives me negative 3 times 3 is negative 9 plus 6, a negative 3, equals a times negative 3 plus 3 is a times 0. So we can see that that term is going to cancel. B times x, which we're saying is negative 3. Negative 3 equals negative 3b. So b is 1. We have a is 2 and b is 1. Looking back at our decomposition, we have a is 2. So that would be 2 over x. Plus b is 1, so 1 over x plus 3. This is our decomposition. If we were to get a common denominator and add these two fractions, that would take us back to our original expression.